thank you very much for giving me the opportunity to speak. I regret to say, though, that it's all bad news which I'm about to present. This is meant to be an overview. What I'm going to be doing is giving an overview, an introduction, a beginner's guide, if you like. For many of you here, this will be repetition. For some of you, it will be new, and maybe there'll even be one or two surprises for those who are familiar with the problems. What I'm going to do is first talk about a little bit about what the nuclear fuel chain is, and then because uranium exploration is going on in several parts of the region, I'm going to say briefly a few things about uranium exploration, some comments on radioactivity, specifically the cancer among uranium miners. One of the major problems is the large volume of wastes produced from the uranium mining industry, and the related contamination of the surrounding environment, and then where you can get some more information. Here we have a graphic made by an artist in Sweden about the nuclear fuel chain. Kärnbränslekedjan in Swedish means nuclear fuel chain. And there's several things to notice about this diagram. At the very beginning here, if you can see this red dot, there are some indigenous people. One of the main problems of the nuclear fuel chain, which is simply the steps involved to process uranium, are that indigenous people are often at the beginning of the chain and other parts of the chain as well, but uranium mining often takes place in the traditional areas of indigenous peoples. Specifically important to note about this diagram is the route. A uranium mill is usually right at the site of a uranium mine in order to minimize transportation. But what's most important to notice here is that it's the same facilities that are used to produce nuclear weapons as are used to produce the fuel for commercial reactors. You can see here, this is an enrichment plant, and from an enrichment plant, you go to producing directly to nuclear weapons, or you go to producing fuel for a commercial reactor producing electricity, but it's the same enrichment plant. A few words about uranium exploration. Now, this is something that should never be done in a PowerPoint presentation, showing text that you can't read. But what I want to say is that this area, the district of Salmon Arm, which is in the Western Canadian province of British Columbia, that as a result of a government inquiry that took place in 1980 in British Columbia, the BC Medical Association, the Association of Medical Doctors, determined that uranium mining was dangerous to people's health, and uranium exploration, particularly because aquifers could be intersected by drilling and the radionuclides spread through the water. So because of that hearing and because of the views of the BC Medical Association, this district outlawed uranium exploration in their watershed. Now again, another example of a slide that shouldn't be used, but you can see the letterhead of the province of British Columbia up at the top, and the text here says, government confirms position on uranium development. It's dated April 24th, 2008. So they reconfirmed that it is illegal to explore or mine uranium in British Columbia. Other parts of Canada and other parts of the world, simply exploration of uranium have been banned, simply because of the danger of uranium ore bodies being intersected by a drill and the result spread of radioactive materials. Radioactivity is, of course, one of the main hazards of uranium mining. All mining has its impacts, but what's special about uranium mining is the extra concern of radioactivity. And if you're not familiar with this concept of a decay series, it's one of the major aspects that understanding it can help you understand why the nuclear industry, in particular uranium mining, is so dangerous. Uranium in the ground, in its natural state, is made up about 99% of this material called uranium-238, and less than 1% uranium-235. It is that uranium-235 has its own decay series. It's the uranium-235 that the nuclear industry is after, and it has to be a certain percentage to be able to use in nuclear reactors, and that's why it's called enriching uranium, because you increase the percentage of that uranium-235. But this concept of decay series, that a material goes through a process, is very important in terms of understanding the dangers. A similar process is rust, but of course it's different. A metal will oxidize and change form. Well, radioactive materials are constantly changing, and uranium has to go through these 14 different steps before it becomes so-called stable. Every time it changes from one step to the next in the chain, there is a release of radioactivity, different forms of radioactivity depending on the isotope. Now, you can see here that I have in red these 4 isotopes. They're called the radon daughters. And the reason why they're so dangerous is because radon is a gas. And when you think of it, it's quite fascinating that in nature you have a material that's changing from a solid to a solid to a solid. Suddenly it turns to a gas, spreads throughout the earth, disintegrates, bang, 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 in 3 minutes here, 27 minutes there, so on. So it's about a half an hour, a little less than a half an hour, a little more than half an hour. You've got these 4 disintegrations, it's back to a solid, and settles down to the earth. So there's in effect, there's a natural process of dispersing the radioactivity. But what is especially dangerous from radon is if you get it inside your body, and then it decays. Within a half an hour, you've got these high energy disintegrations in your body which can lead to cancer. There's a lot that can be said about uranium decay, but I'm going to go on. Uranium miners can die of cancer and contract serious lung diseases as a direct result of working in uranium mines. I began working on the problems of uranium mining in the late 1970s and worked quite intensely against uranium mining in Canada and other parts of the world in the 1980s. And we fought tooth and nail to just spread information about the dangers of the radioactivity to the health of uranium miners. And at that time, it was not generally accepted that there were health effects. The government and the industry, even health professionals, often tried to deny it, though there were a few that said there were dangers and they were considered some kind of a lunatic fringe often. But here we have a cover of the leaflet of the Europe Electrical Traders Union. This is their brochure from the summer of 2010. This is the Electrical Trade Union in Australia. And here we have, this top part is from the cover, and then there's page 24. Here it says that ETU, the Electrical Traders Union, no to uranium. This was in the summer of 1980. They actually refused to allow their members to work in uranium mines. And why was that? Well, interestingly, in 1990, in the United States, an act was passed called the Radiation Exposure Compensation Act. The act was specifically made to compensate people who've been exposed in downwind areas from nuclear bomb tests in Nevada. Here we have Nevada. That light green color is the downwind. The yellow color is uranium worker states. So the act was amended in 2000 to include uranium mine workers, mill workers, and transporters. What happened was that you can read the act, you can find it online. I'll be giving you a reference where you can find it if you like. Well, you can go into the Justice Department, www.justice.government, and find it. And you can read that what the government did then was they actually apologized to the people for these, for the suffering that was caused, and they offered money in compensation. Now again, another slide which should be used in the PowerPoint presentation, but for my purposes, I can tell you here, it shows that up until the 2nd of December, there were almost 7,000 uranium mine, miller, and transport workers compensated for their health problems. And then many more downwinders. The significance of this has yet to be assessed. What it means in terms of the conventionally used model for determining risks or more appropriate models remains to be assessed. But what's especially important with this is that it's no longer can be said that there's a lunatic fringe of health professions or environmental activists with long hair and beards who are saying uranium mining is a problem. Now, the government of the United States has officially acknowledged and is compensating for not only lung cancer, but a whole series of diseases. This photo was taken in September this year, and I don't know if you can see here at Grants, New Mexico. It's a close-up of the slide. Just last week, in order to get an update, I phoned this number to find out how it was going, and they've been representing many people who've worked in the uranium industry and have received compensation. And what they're particularly trying to do is to work with people after the period of compensation. The Act has many interesting aspects. One of them is that they compensate from 1945 to 1971, because at that point, they say it was particularly military use of uranium. The United States was making nuclear bombs, so they had to compensate the people that were involved in the bombs production. And that's another admission. Again, we used to, in the environmental movement, argue that there was a connection between the civil and military use, and often government and industry tried to say that wasn't true. Now the US government has admitted these mines were used for the production of nuclear weapons, and that's why we're compensating. There's another law company, the American Way. If the lawyer can make money at it, then they'll put up a sign for it. In any case, it's saying here, helping uranium workers live at home. And another reason why I contacted the people with the billboard was to find out what kind of workers they were helping. And indeed, it is people suffering from cancer, different forms of cancer, who are living at home, waiting to die from that disease. Uranium mining rapidly produces large volumes of liquid and solid waste, which remain hazardous forever. I've talked about worker health. Now I'm going to say a few words about the strictly environmental problem from uranium mines. Uranium mines are of two main types, open pit mine like this one, or underground mines. And there's another type of mine called an in situ mine, where chemicals are pumped into the ground, taken out to get the uranium. As I said, a uranium mill is usually located right near a uranium mine to minimize transport. Here's a mill facility. At the corner of this road here, every adult almost from the nearby native community blocked that road, simply because they hadn't been informed about what was going on in the mine. This was in the mid-1980s. Finally, after the native people in the community blocked that road, the mining company had a meeting with the people, and they showed, amongst other things, a picture like this. And it was quite something to be present at that meeting and see how the engineers stood up and was so proud of how they managed to figure out how to dig a hole like that and get the material out. Where an elder from the native community stood up and said, "I'm shocked. You've destroyed the earth. This was my livelihood, and look what you've done." So what I'm saying is here, is this an admirable wonder of engineering achievement or a despicable method of destruction? There we have a picture of the clean nuclear industry. Nuclear power plants, of course, you don't see that waste outlet pipe. What's important about that waste is that it contains about 85% of the radioactivity. If you remember that decay series, what they're trying to get out is the uranium-235 and the uranium-238. All the other isotopes in that decay series come out the end of the pipe as waste. Uranium mining has a catastrophic effect on the immediate surrounding environment and contaminates the downstream area. Another poor slide. What it basically indicates is that some of the heavy metals downstream from uranium mines exceed the drinking water regulations. Standard practice, can't mine uranium without polluting large quantities of water. The radioactivity released from uranium mines accumulates in plants and animals downstream to levels thousands of times the surrounding water concentration. That radioactive material can, of course, eventually reach people. Here we have a fish that was caught downstream from uranium mines, and if there's some observe it deeply, you'll notice that the mouth of the fish is shaped so they can specifically eat off the bottom. It's called the sucker. Uranium sinks down to the bottom because it's heavier than water, and the bottom feeders accumulate more than other species. This fish had many more times the allowed levels of radioactivity in its flesh than permitted for consumption. It also was totally blind, and blindness in fish has been shown to be, through experiments in other places, a result of low-level radiation. This is a chart just showing the different periods of uranium mining. Uranium mining in the early 60s was characterized by direct dumping. Nowadays, uranium mining isn't so blatant with the pollution. Nowadays, they have liners and so on. But what I should have added in this chart was that there's a new era now, the post-U.S. Radiation Exposure Contamination Act period. Now all uranium miners know that they're possibly going to get cancer. Let's see. Well, there's a summary of what I've told you. I won't repeat it. You can look at it in the PowerPoint presentation online. For more information, I suggest the World Information Service on Energy Uranium Project. There's abundant information there. To get information about the U.S. Radiation Exposure Compensation Act, I suggest this post71exposure.org, where they're fighting to get compensation for miners after that period that the U.S. has admitted was only for production of nuclear weapons. And then the site that I work for, which covers general information, nonuclear.se. Thank you.
Dėkui Mailsui iš Švedijos. Dabar kalbės skandinavų kitas atstovas, tai yra ponas iš Suomijos, ponas Harkoninas, jisai kalbės apie atominę industriją. Prašom.